So power is the cube of wind speed. So definitely get it up as high as you can. And one of the biggest concerns that comes with tower design are the guy wires. So a lot of people say, well, I don't want those guy wires in my yard. And there are options for that. You can get what they call a monopole or a single freestanding structure. And it has a giant, I shouldn't say giant, but a fairly big concrete base that has to go down a long ways and basically anchors it without any guy wires at all. Guy wires are just supposed to give it stability in all 4 directions or 3 directions, depending on the turbine. If you go up beyond, say, 60 feet in the air, then you definitely will have to guy it. Just a sec. You have to guy it, and the guy wires, basically, a good rule is if you're going to go up, say, 75 feet, you need to draw a circle around the center of where your tower is of 75 feet in diameter. So you need to have anchors that are going to be 35 or 37.5 feet away from the anchor, from the center pole, all the way around your turbine. So you need to have that kind of land mass to do that. Question?
Can you explain power as the cube of wind speed?
Yeah. So basically, I don't know how technically to get into this, but there are really 2 big things that drive the power out of a turbine. One is called the sweep area of the blades, and that's basically how much, if you were to take, if there are 3 blades and it makes say a 12-foot wingspan, or a 12-foot wingspan, and you calculate the area of that, that would dictate how much power you get. So the bigger the fan you have, the more power you can get out of it. The second piece of that pie is how fast the wind is going. And I showed that in the previous graph. But basically, if you say, in rough terms, that that's how you calculate your power, is that its power is equal to the area of the blades times the velocity of the wind cubed. So if you go from 10 miles an hour up to 12 miles an hour, that 2 difference cubed basically, really adds up quickly. Does that make sense? There's a fudge factor in that as well. It's like 0.27 times all that, and that will give you a rough approximation of power. I think I have that in here. So the very first thing about wind is that the only 2 things that really matter, in my mind, maybe this is because I'm an installer, but reliability and safety. We install solar as well, but I would say that they're completely different things in a whole bunch of ways. The first is that, like Dr. Pierce said, that solar is steady state. So once it's up there, it just sits there and makes electricity for a long time. Wind can do that as well, but it has moving parts. It has the central bearing that the blades are on, and a lot of the motors have brushes in them. There are hinges and swivels for the turbine to move and catch the wind. There's also pivot points for the tails to move, things like that. So basically, those are all things that you really need to think about and talk to your installer about to understand which turbine is the most reliable. It's kind of like a car. I mean, you wouldn't buy a car and expect to do nothing and have the engine run for 20 years. If you take care of it, then you're going to get a long lifetime out of it. And when you go into it, you need to anticipate those operating costs and annual inspections and things like that. The other thing is that safety is really important because in contrast to solar, wind, you have these big hurricanes and things like this that come through. It's not like you have a big flash of sunlight that you need to deal with. So it's a bit wild like that, and you need to make sure that the safety mechanisms are robust enough to handle it. Up here in Ontario, we don't have to worry about things like harsh salt or maybe ice loading on the blades and things like that, but in other places you need to worry about those things. So whatever's specific to wherever you're going to install the turbine, you need to really think about that. And of course, it all has to be done to proper electrical standards. Lots of home jobs and stuff going on, but have the electrician come in, take out the permits, and do it right. The other big thing is that the towers really require the proper structural engineering. And we were working on a job where we put up that turbine that you saw in the previous picture, and I heard about a gentleman down the road who was putting up a similar one, and he thought he would just make the tower himself. And you can totally do it. Like, there's nothing magical about what we did. He just cut some corners, and the tower collapsed when he was putting it up. And so it's a lot of money and it's a lot of time, and it's just really unfortunate, because if you followed the drawings that are provided by the manufacturer, it wouldn't happen. So I'd say really stick close to what they recommend from the manufacturer. And if you're doing anything weird, if you're installing it on a hill or in a piece of granite or something like that, have a structural engineer, or your installer get a structural engineer to make sure that it's all good. Like I said, electrical connections have to meet your safety requirements. And the other big thing is to maintain the setbacks. So this is the distance from your home, from your other buildings, and from your neighbors. There's obvious safety concerns with that if the tower does happen to fall over. You don't want it to crash on anything. But the other thing is that there is a bit of noise that comes downwind from the turbines as they're spinning. It's not an excessive amount of noise, and again, with this feel of people liking to see their wind turbine going, some people, like to hear it. And they know that they're generating their electricity. So, it's all different strokes, right? But your neighbors might not think the same. So keep a bit of a buffer from them. Generally, this isn't for suburban environments at all. This is if you have a couple acres of land or things like that where you can provide a little bit of a buffer. In a far distant second, you need to start asking yourself, how much power do I need, do I want, and how much do I even use now? A lot of people have no idea. I think perhaps it was you that said, if I have a 2,000 square foot home, how much power would I need, or a question along those lines. That's another very common question. I have 3 teenagers, 1,500 square foot bungalow, how much power do I need? It has nothing to do with the size of your home. It has everything to do with how you use the power. And it's not a lot to do with lights. People say, I'm always on my kids about turning the lights off and things like that. It's the heavy hitters or the phantom loads or things that we don't really think about. Things like electric clothes dryers or electric hot water heaters, baseboards, electric ranges and ovens, things like that we really need to understand. So the average home, this is in all of our Canadian gluttony, this is how much we use. 30 kilowatt hours a day. This is a good benchmark for people, because a lot of people that come in and want to do this stuff are well below this. But a lot of people are at this. And it's not any fault of their own. It's mostly because we've been offered this really cheap electricity. And for a lot of people, the appliances are cheap as well. And it makes sense. We go with it and we use a lot of electricity. You need energy in your homes. And the quest is to try to use as much renewables as you can to augment that 30 kilowatt hours a day. So how much of that do you want to make? And how much is reasonable for your area, for how much wind you have? You look at your home, is it oriented to the south? Do we have good wind? And then your ideas start popping in your head about wind and solar.